cube root of 8 is 2. 2 to the exponent 5. But I need it as a power of 4. So I'm going to multiply 5 by 2 inside and divide it by 2 outside. So that's going to give me 2 squared, which is 4. 5 over 2. I'm going to write these questions as a power of 5. In other words, what exponent should 5 have so that when I raise 5 to that exponent, I'll get 20. So if I take the log base 5 of 20, and I raise that to 5, 5 to the log 5 of 20 is going to give me 20. Same logic, 0.8. 5 to the log 5 of 0.8 Notice that 27 is a power of 3, so I can write that as 3 to the exponent 5x equals 3 cubed, which is 27, to the exponent x minus 1. This is going to give me 3 to the exponent 5x equals 3 to the exponent 3x minus 3. My bases are the same, so this allows me to say that 5x is equal to 3x minus 3. (5x minus 3x is equal to 3. 2x is equal to 3. X is equal to 3 over 2. As I'm writing 8 and 32, I can recognize that I can write 8 as a power of 2. I can write 32 as a power of 2. 2 to the exponent 3 will give me 8. 2 to the exponent 5 will give me 32. 3 times 2x is 6x. 3 times 1 is 3. 5 times x, 5 times negative 3. Since my bases are the same, I can set my exponents equal. 6x plus 3 equals 5x minus 15. 6x minus 5x equals minus 15 minus 3. X is equal to negative 18. So we're talking about 50 milligrams of cobalt 60. That becomes 40 milligrams after 1.6 minutes. We want to find the half-life of cobalt-60. Alright, so we know that, for example, it started out as 50, but it became 40 after 1.6 minutes. And we want to find out what this T is to find out the half-life. So, the first thing I'm going to do is I'm going to divide both sides by 50 from there. (40 over 50) is equal to 0.5 to the exponent 1.6 over t. I take the log of both sides. This will bring my exponent to the front. So I've got log of 0.8 I'm going to do some cross multiplication. T times log of 0.8 equals 1.6 times log of 0.5. Divide both sides by log of 0.8. This isolates t for me. When we do that calculation, that gives us 4.97 minutes. Which makes sense. If every roughly 5 minutes it's becoming half, seems to reason that in 1.6 minutes it would go from 50 to 40. How long will it take for the sample to decay to 5% of its initial amount? Alright. So 5% of its initial amount, which was 50, is 2.5 grams. Sorry, milligrams. So what happens to our relationship is 2.5 equals 50, 1/2 t over 4.97. That's not very clear, so I'm just going to rewrite that whole business. So far that's what we have. Okay, so our original is 50 milligrams. I want to go to 2.5 milligrams. We know the half-life is 4.97 minutes. So this is what our situation is. This is what we want it to become. This is what it starts off. It's a half-life situation. It becomes half every 4.97 minutes. We want to find out what t is. So I'm going to start off by dividing both sides by 50. So these two go away. If I take 2.5 and divide by 50, I'm going to get 0.05. On the other side I have 0.5 to the exponent t over 4.97. I'm going to take the log of both sides. What that will do is bring this exponent in front, making the equation look like this. Remember, we're trying to isolate for t. So I'm going to multiply both sides by 4.97. And now to isolate for t, I'm going to divide both sides by log 0.5. Giving me t is equal to 4.97 log 0.05 divided by log 0.5. So 4.97 times log 0.05 divided by log 0.5 gives me 21.48 minutes. So just imagine you started off with 50. After 4.97 minutes it becomes 25. Another 4.97 minutes it becomes 12.5. Another 4.97 minutes it becomes 6.25. Then it's going to become 3.12. So 5, 10, 15, 20, and then roughly 1.5 minutes later it'll go from 3.12 to 2.5. Okay? Question number 5 says solve exactly. The first question is 3 to the exponent x minus 2 equals 5 to the exponent x. So I'm going to take the log of both sides. That'll bring these exponents down. So multiply this out, that's going to give us x log 3 minus 2 log 3 equals x log 5. I'm going to move this one to this side, this one to this side. That's going to give me x log 3 minus x log 5 equals 2 log 3. X times log 3 minus log 5 equals 2 log 3. And so x is equal to 2 log 3 divided by log 3 minus log 5. That's the exact value. And then question number 6a says find what that is to 2 decimal places. So to 3 decimal places, x is equal to negative 4.301. So I'm going to take the log of both sides. So it's going to bring the exponents down in front. Now what you want to do is multiply these out and rearrange so all your logs with k are on one side, everything else is on the other. K log 2 minus 2 log 2, k log 3 plus 1 log 3. I'm going to bring all my k's to one side and all my other terms to the other. It's going to give me k log 2 minus k log 3 equals log 3 plus 2 log 2. Factor out your k. And to solve for k, that's going to be log 3 plus 2 log 2 divided by log 2 minus log 3. That's the exact value. And for number 6b, k is equal to negative 6.129.